Students, now I am going to explain about the diode. So diode symbol will be like this. So this is the diode symbol, circuit symbol. This side is P and this side is N. So it is the circuit symbol for diode. So already explained about the diode. Diode is the device which converts alternate current into the direct current. So it is the combination of two semiconductors like a P-type semiconductor and N-type semiconductor. How we will make this diode? First you take the fourth group element like a pure type semiconductor like a silicon. So this is the silicon. So it is the silicon chip. So in M.Tech, in M.Tech we have one specialization like VLSI design specialization is there. So VLSI design is nothing but very large integrated circuits. So they are manufacturing all the boards on this silicon chip only. So it is the silicon chip or means the fourth group element like it is a pure type semiconductor. Now half of the portion you dope with the third group elements like gallium. So if you dope with the third group element, so majority carriers are the holes. Holes are imaginary. So if you dope with the third group element here, so majority carriers are the holes. So here majority carriers are the holes. Means it becomes as a P-type semiconductor. It becomes as a positive type semiconductor. P-type semiconductor is nothing but positive type semiconductor. If you dope with the third group element, with this fourth group element, so it is the third group element. If you dope the third group element, it becomes as a P-type semiconductor. Here majority carriers are the holes and minority carriers are the electrons. So here some minority carriers are there. So minority carriers are the electrons. Now the rest of the portion you dope with the fifth group element like nitrogen, phosphorus, arsenic, antimony, bismuth. So if you dope with the fifth group elements, majority carriers are the electrons. Here, so majority carriers. So these are the majority carriers. So majority carriers are the electrons and minority carriers are there. So minority carriers are the holes. Minority carriers are the holes. If you dope with the fifth group element, it becomes as a N-type semiconductor. So it becomes as a N-type semiconductor. So it is the P-type semiconductor and it is the N-type semiconductor. The combination is the diode. Now what is the inner function? That inner function you can see. So due to electrostatic force, suppose two charges are separated by distance d, then the force of attraction or repulsion between the two charges is directly proportional to product of their charges and inversely proportional to square of the distance between them according to the Coulomb's inverse square law. So according to the Coulomb's inverse square law, so here also you have the electrons in this side, you have the holes in this side without giving any potential difference, without connecting any power supply. These electrons are migrate from N region to P region. These electrons are migrate from N region to P region. So N region to P region. N region to P region. Even in the P region you have the electrons, migrated electrons. Displacement of the electrons is nothing but holes. So here holes will create on N side. So here holes will create on N side. So between them covalent bond is there. So they make the covalent bond like this. So covalent bond is there and they'll make the barrier. So this is the barrier. So that barrier is called potential barrier. So this side you have positive and this side you have negative. Positive, negative. Of course it's like a 0.6 volts or something is there. So that potential barrier is, value of the potential barrier is 0.6 volts or 0.7 volts. Like that potential barrier will generate between the P-type semiconductor and N-type semiconductor and in the middle of the diode. Okay, right. Now this diode is connected in forward bias. So now we can see the forward bias. In forward bias, what we are doing? So this P side is there, no? This P side is connected to the positive terminal of the battery and this N side is connected to the negative terminal of the battery. So this P side is connected to the positive terminal of the battery and N side is connected to the negative terminal of the battery, and this voltage you goes on increasing this voltage like 0.1 volts, 0.2 volts, 0.3 volts and so on. If it goes on increasing just to 0.1 volt, 0.2 volts and not 1 volts, 2 volts, 3 volts. Why? Because here this barrier will break by giving 0.6 volts only, by giving 0.6 volts. So you have to apply this voltage by using voltage regulator. You apply this voltage with 0.1 volts, 0.2 volts, 0.3 volts, like that. Not for 2 volts, 3 volts, 10 volts, not like that. If you apply more amount of voltage, automatically the diode will break up and it may be destroyed. Okay, right.